Hi, we're team number 6 and we're going to talk about the Doppler effect. The team is constituted by This is our problem, and it's the next one. As a train moves toward an observer, the pitch of its whistle sounds higher to the observer than it would if the train were at rest, because the crest of the sound waves are compressed closer together. This phenomenon is called the Doppler effect. The observed pitch P is a function of the speed V of the train and is given by this formula, where PO is the pitch of the whistle at source, and SO is the speed of the sound in air. And this formula we're going to substitute it by the next value. The problem that we need to solve is the next one. For this, we have to suppose that the train has a whistle pitch at PO equals 440 Hertz. And SO is going to travel at 332 meters per second. So we have to graph the function of y equals P of V using a graphing device, and we have to answer the next question. How can the vertical asymptote of this function be interpreted physically?
First, we have to know what is the Doppler effect. The Doppler effect is the variation on the frequency of the waves caused by the movement either of the source and or of the observer.
And substitute the values of the formula by adding in PO 440, and for SO we substituted by 332 meters per second.
Okay, now to get the asymptote, the only thing you have to do is to substitute B with a number that the denominator gives 0. So to know what number B can be, this number would be 332, because 332 minus 332 it will equal 0, and it can be like that.
Okay, so after graphing we can solve the question. Here you can see our asymptote is located at 332. This is the sound barrier. And here you can see this is the speed of the train. The speed of the train cannot cross the barrier of sound because the sound will go slower than the train, and you wouldn't hear anything. So that's why here's the limit, and the speed of train can cross the limit.
This is the flowchart to conclude the solution of the process. First, we start. Then, we write the function given, which is this one. Then, we substitute the values of the equation, which is like this. And we solve the equation. We graph the function. Is it asymptote? If it's yes or no. If it's yes, you analyze the graph, get the conclusion from it, and there's the end. If it's no, you start all over again. Problem, we found out that the asymptote represents the sound barrier, which can never be crossed by the train, because if this happens, the sound will go slower and slower, and it wouldn't reach it. If this ever happens, there will be a sonic explosion. The asymptote goes to the infinite, and as this happens, the graph follows the asymptote, and at some point, it reaches the infinite of sound.